from last year, from two numbers. Okay, so first up, we're going to talk about interval notation, right? And there's actually, I think, 10 topics on the first 10 pages. We're going to try to do 5 topics today. So interval notation. You guys should know that when you see, oh, I got to record. Hold on. Here we go. I am recording. Sorry. All right. Obviously, what is this symbol? Yeah, right. Pretty easy peasy. That's positive infinity, right? And what's the symbol right below it? Negative infinity. There you go. And what does that really mean in terms of interval notation? Like, for example, if I say x is greater than 8, right? Then you're starting at 8, not inclusive though, and you're going in what direction? To the right or to the left? You're going towards positive infinity, exactly. So you'd write like this, right? We know that. The parentheses is obviously for when it's not included. The brackets are for when the number is included. Can all review. Obviously, when you have like a less than, a greater than, a positive infinity, a negative infinity, you're going to use the parentheses. How come we don't do a bracket for infinity though? Because yeah, what is infinity, right? I mean, do we know what that number is? No. It's this abstract idea of this number that just keeps getting larger and larger and larger, right? We don't know. But if you do have like this here, x is greater than or equal to 8, is 8 included? Totally, right? So I'm going to put a bracket because I have to show that the 8 is included. So the brackets are used for when you're including a number, or when you have less than or equal to or greater than or equal to. So again, just take a little bit, take a moment to simmer on this, right? Again, positive thing going to the right, like the number line, right? To the right. Negative going to the left. If you're not including the number, for instance, we're including the brackets. Obviously, when you less than or equal to greater than to include it, this less than greater than positive and negative. It's obviously. So now let's actually practice writing interval notation for the inequalities down below. Let's draw them, and then we'll move on. So interval notation should be pretty straightforward. When was the first time you guys saw interval notation, by the way? Did you guys see it last year for the first time or prior to that? Last year saw it for the first, okay. That's pretty easy to pick up. I mean, it's not, and that's kind of the standard. Just have to get used to it. As you guys move on to AP Calculus, whether it's AB or BC, that's just what you do. We do interval notation. So let's move on. Let's do these problems here. So I'm just gonna put 0 somewhere in the middle, just because I want to. I feel like it. So I'll put 0 in the middle here. And then I'm gonna put -1 right here. I'll put 7 kind of like right here. Obviously, don't worry about negative infinity or positive infinity. I'll put 2 right here. Now, from a drawing perspective, I'm starting at -1, but is -1 inclusive for part A? No. So what do you do? How do I do a circle? Do I do close? What do I do? Yeah, totally pain. Thank you. I always find it kind of weird when you say "oh" because the circle is closed technically, but it's not filled in. Right? I know what you mean. Yeah. Hollow. There we go. Yeah. There, a hollow circle, right? And we're going to the right. Now, interval notation, how am I going to write it? Parentheses, -1, comma, infinity. And you don't have to write positive next to infinity. If you don't write a symbol next to infinity, the default is positive, right? We know that. So, but if you want to write positive infinity, go ahead. I don't care. But it's infinity. Now, next up, we're starting at 7. But in this case, what kind of circle or dot am I doing here? Yeah, totally filled in. Filled in. Yeah, it's okay. I know what you mean. Don't worry about it. And you're going to the left. Now, in this case, order matters, right? You don't write the 7 first. You write negative infinity first, as we're going from left to right. So it's always from left to right or numerical order, right? So make sure you're very careful about that. We're going from negative infinity to 7, and 7 is inclusive. Now, next up, what do you think's happening here? I mean, if you were to express this in words, what's my range here? Everything, all real numbers, totally. So everything gets shaded. And you just do that. otherwise known as all real numbers. Now, this is kind of a fun one. 2 is not included. So if 2 is not included, what is included? Everything else. Exactly, totally. Now, how am I going to draw this on a number line? And then shade both everywhere else. Right, exactly. And then how am I going to write that as interval notation? What do you guys think? You're good. Yeah. And sorry, Kay, I saw your hand raised too. Thank you though for raising your hand. But 2 is not inclusive, so you got to put parentheses, and then you have to do a union. Now, are you guys familiar with these logic operators, the U and upside down? Have you guys seen that before? So that, what does that stand for? Union. Union. That means that it's one or the other, right? So it's either in here or in here. So it's actually an or symbol, believe it or not. It's not an and, because can a number be in here and here at the same time? No, so it's actually an or, just so you think about it. It's actually an or, so one or the other. This is an and, because that's an intersection. We're never going to see that for interval notation because you're not going to really be intersecting these sets. But if you're doing logic class down the road, maybe for the advanced topics, you deal with this stuff. Eddie, go ahead. Isn't the upside down one using probability? It can be, yes. Which actually, I don't think we cover in this class. I don't got time. I love probability. It's a great topic, but just kind of just gets tossed aside. But yes, sometimes it is using probability. All right. So I think we're cool. All right, let's move on to domain range. Perfect. All right, so as you can tell, my handwriting can be a little messy at times, so I'm going to use a text box to fill these things out. Okay, domain. You guys should know this by now. You guys should be very, very comfortable with domain. It's a set of all possible x values that yield a real value output. Let me resize that just a tad. Awesome, that fits very nicely. There we go. Ooh, look at that. Perfect. So instead of all possible x values that yield a real value output, just means x, right? Just give me the x values. That's all it is. So the range is going to be somewhat of a similar definition. Yeah, totally. Instead of all possible, but we're saying real, right? So we want to be very careful with how we phrase this. Real value outputs. And let's resize that. And please, guys, do not hesitate to interrupt me if you guys are stuck or if you have questions. Totally okay. Instead of all possible value outputs, right? Okay, and that's y, right? So we know this is bx, this is by. Now there can be restrictions though. This is the part why some people don't like domain range and all the functions we talked about. Remember I put that little schematic 2 days ago and we talked about Star Wars, blah, blah, blah. And, you know, like you have to understand how these functions work. You know, this is the intimate knowledge you need with these functions because there are restrictions for particular functions, right? So usually the default will be this will be the default if no restrictions. If you have no restrictions, obviously you're going to see all real numbers, right? That's the default. Negative infinity. But if there are restrictions, there's usually going to be two things. But, you know, we're going to talk about logs. We're going to talk about trig stuff. There's restrictions with tangent, right? There are restrictions with log, like natural log or whatnot. But for now, we'll keep it kind of simple. Cannot divide by 0. So a good example. What if y equals 1 over x minus 2? So what would be a restriction here? Can't be 2, exactly, right? So then how would I write it? You could write like this, but more formally, you write like this. With a parentheses, of course, right? Okay, so we know that. Can't divide by 0. We're okay with that. Also, you don't want a negative underneath an even root, like 4th root, square root, 6th roots, 8th roots, and whatnot. So any even root, so say, for example, y equals the 4th root. I'm going to kind of do a fun one. 2x plus 5. So what value of x would be restricted here? Or what values? Let me rephrase it. Values are you got?
Anything less than -5.
That's restricted. So we want things that are greater than that. Exactly right. So x has to be greater than or equal to -5 halves, because -5 halves makes the inside of that 0, but we need to keep that inside positive or non-negative, because 0 is okay. So then we would say this, -5 halves to infinity. That's how I'd say my domain there. So any even root, cube roots, all good. Fifth roots, all good. But even roots, you gotta be careful because it would not be real, right? Because again, it's all about real, right? Again, if you look here to determine the domain, consider any restrictions, find algebraically, blah, blah, blah. You guys know that. The range is tricky though. To find the range, really, you're gonna have to look at the graph. So Desmos is gonna be your best friend here. I strongly recommend use Desmos. And plus, it's good. You should be able to see how the graph looks, right? I mean, once you get very good with this, you'll just kind of know, like, okay, you know, this is a rational function. And what are some key features of rational function you guys remember? There's something called an asymptote, good, asymptote, right? There's also horizontal asymptote, like anti-gated, right? Does anyone want to take a stab at what the range would be for this? Anyone have an idea? Right. Yeah, Captain, yes. Yeah. Why can't equal 0? How come why can't equal 0? Dude, go ahead.
Because like 1 over infinity, so it gets closer to 0.
Yeah, because the thing is that the top is what? 1. It can't change. And so the block can get really big. So you have to think numerically too, right? It's kind of like what we call limits, which we're going to get to later in the year. What about this one? You guys have an idea what this range would be without graph, or if you could visualize a graph, perhaps? Someone have an idea too? If you want to try it?
It's just for the range.
Yeah, range. Yeah. Yeah, because this output can't be negative, right? So it could be 0. Yeah. So yeah, once you get more of that intimate knowledge with these functions, sometimes you can just do the range really fast. But graph, if you're not sure, it's totally okay. All right. Let's do some practice problems. Oh boy, we got a lot here. But it's okay. It's good. So I'm going to do a couple, and then I'm going to have you guys do some in groups. I'm going to walk around, see you guys are getting it. So I'll do a couple here. What couple should I do? I should do a nasty one with you guys. I'll do an easy one. No, I'll let you guys do the let me do the nasty ones with you guys. Let's do E and G. I'll do E and G, and then I'm gonna have you guys do the rest in groups. Okay, so let me do E with you guys. Root x squared minus 6x. Okay, so the bottom line is that x squared minus 6x. What has to be true about that for this to work? Okay, go ahead. Exactly, thank you. Greater than or equal to 0. Now, do you guys solve quadratic inequalities in Algebra 2 trig honors? Yeah. Good, excellent. When I taught the class, we did too, so I'm glad you guys did it. So when you do that, what you have to do is did you guys do sign charts? Good, excellent. I'm loving everything I'm hearing. Yeah, because it's not an equation. Like you don't do the 0 product problem necessarily, because figure, okay, what x times x minus 6, great. X, if x is 0, it would be a true statement. X is 6 would be true. But that's not the whole story, right? Because it's an inequality. So what I would do personally is I would do a sign chart. Sign chart is when you draw a number line. You identify what I call the critical points, which are the values that make the expression 0, right? So 0 and 6 are what I call my critical values, because they're important, right? That's why they're critical. My critical values. And then what you do is you do, well, actually, I'll ask you guys, how do you do a sign chart? Do you guys remember? Okay, go ahead. Yeah. Yeah, exactly. Now, let me show you a more efficient way, because what some students will do, they'll plug in a value greater than 6, like say 7. They'll plug in a value between 0 and 6, like 1. And they'll plug in a value less than 0, like -1. Is that how you guys test all the values, right? Okay, I'm going to show you a better way. Just test one of them. Test the one on the far right. If I plug in 7, of course that's 7, and that's 1. 7 times 1 is positive. Is that true? Yeah. Great, okay. And you guys put a plus symbol up above, right? Okay, without testing the other two, I know it's going to be this. I don't need to waste my time testing the other two. How do I know that? Why do I feel comfortable doing that even testing?
The critical point means that it has to go to 0. So it continues to 0.
But also there's another reason too. Look at the factors, right? The factor, what's the exponent for this factor here? That's all this one. Yeah, so whenever these exponents only occur once, there's not a square symbol, then you're going to see alternation signs.
Because it has to be a sign change, because guess what? What happens at 6? What happens to this expression once x gets less than 6? It converts from positive to negative. So we see a sign change, right?
Let me throw you guys a curveball here. I love baseball, so I'll use a lot of baseball analogies. All right.
What about that? What happened now?
Then 0 through 6 would also be positive.
Yeah.
So what?
There's no sign change because of the square symbol, right? Yeah, there's
It would be that. So I'm forcing you to really understand what's happening here algebraically and numerically too, so you don't really waste your time. That's what I like. What if x minus 6 was absolute value? Same thing, right? It's just exactly. You know, you wouldn't have a sign change, right? And by the way, graphically, you guys remember when the graphs used to bounce off the x-axis, right? That would be a bounce because it's bound because of this, right? That's what happens.
a lot of people just memorize. Well, if it's even, I don't know. No, you do know. Numerically, you see what's happening. You know what's happening. So anyway, that's how I would recommend you guys do your sign chart. Just test the far right and then analyze what's going on in the expression, and you should be able to figure out the rest. If you want to plug in, go ahead. Just not terribly efficient, you know. So all right, let's do oh, I still need to write the domain. Sorry, got a little carried away here. Okay, so we know that's negative and positive, so let's write the final answer. The final answer is going to be this: negative infinity to 0, but 0 is included because it's a square root, not a fraction, and from 6 to infinity. So that's your final answer. And I think we just asked for domain. Is that right? Yeah, we don't care for anything else. So anyway, okay. All right, let's try one more, and then I'm gonna have you guys do some in groups here. And just so I don't mess up the timing of things today, we'll finish at 9:40. Okay, cool. All right. Okay. Schedules just drive me nuts. All right, let's go G. Okay. Oof, lot of things going on here. Let's kind of break it apart. What are some things what are some observations you have about G? Like, what are some things that are not cool? Abby, go ahead.
First term, not squares.
Yes, X cannot be what then? I totally agree. And then this one here, that's a pretty easy one to factor. By the way, factoring, gotta be like that. You guys gotta go fast with factoring. You guys have been factoring for 4 years now, so boom, 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 right? Now, in this case, I could do a quick sign chart, but I kind of know that 1 and 3 are my critical points. And I know it's gonna be positive here and negative there, right? So actually, you should do the sign chart. I said you can kind of, you should do a sign chart. But 5 and -5 are not included, right? So this is gonna be a fun one. This is a really fun way to write this. It's gonna be quite intricate. So I'll put 5 and -5 here, obviously. And obviously they can't be included. So what do you guys think? Anyone want to take a stab as saying all this all and glory? You want to try that? Go ahead. Tell us. Yeah. And parentheses are on -5, right? Yeah. Keep going. Yeah, I agree. Mm-hmm. Mm-hmm. Nailed it. Yep. So you have 4 intervals actually, which is kind of weird, just the way it is. So if I were to actually draw it more appropriately, it would look kind of like this. Let's get a highlighter here. And there's going to be open circles. Oh, hold on a sec.
Yeah.
I made a mistake. Good. I made my first mistake today. This is why it helps to draw, because then I realized when I checked myself. So always check yourself, right? I'm human. I'm going to make errors. You know, I'm not perfect. But then I realized when I put those circles, wait one sec. Those are close, right? Yeah. So I messed up. My bad. Those should be brackets. It happens. Now, but what if it was like 1 over that radical? Then you don't include them, obviously, right? Because you can't. But we didn't have that. Okay, now I'm gonna give my voice a break. I'm gonna give you guys a chance. I don't know how long it'll take you guys. working your table groups. Let's do A through D and F and H. Let's see how it goes. I have the answer key here. I'll let you know if you've got it. Also, I'll probably write the answer on the board anyway. Cool. Let me pause the video.
Parentheses.
This one's
Yeah,
yeah. Okay. So far we're okay.
We're okay. A, B, C, D. Okay, we'll give those first four. All right, let's look at those last two.
Let's go on the last two here. F and H. Well, you can't. It's tricky. So the bottom can't be 0, so you can't include 7. We know that. 7's not cool. And also, it has to be bigger than -2, right? Because you can't have a negative beneath the radical. So before I look at the answer key, I think we're going to start at -2. We're going to go towards 7, but not include the 7, and then keep going on forever. Yep, that's it. That's okay. We're okay with that? Yeah, good. Okay. And then last one's a doozy. Okay. Well, obviously x has to be less than or equal to 12. X cannot equal 8, and I don't think there's anything else we have to worry about. So we go from -infinity to 8. Don't include the 8. 8 to 12, you can include the 12. Yep, cool. Excuse me. All right, let's move on. Thanks, appreciate it. Okay, and the more I think about it, I just want to do up to page 5 today because inverse functions, the sixth part of this, or the sixth topic on these notes, is really long. I'm going to save that for Monday. You guys are going to be sick of me if I do more than 5 pages today. All right, combination of functions, right? Pretty straightforward, right? Like you're adding 2 functions, right? Or if you see the symbol here, it's adding 2 functions, right? See that symbol? See that? See that? Fine. Of course, guarantee that g of x is not equal to 0, right? So now the trick, this is a little trickier. At first, combine the functions for simplifying. Look for possibilities that make the expressions undefined in case how the domain is set. So before we combine these two, let's see what makes these restrictive. Because anywhere in the process of combining these functions, if there's any restrictions anywhere along the way, it's got to be excluded. You can't just look at the final result. You also have to look at the intermediary steps too, right? And begin. So you have to be mindful about that because it's just going to crap out if you were to put, like, say, in a program, like say you're like building a Python code or whatever, and you're doing some sort of mathematical stuff in there. It's going to freak out, right? Because anywhere along the way, it's just not going to like it, right? So clearly, we know that the restriction here is you can't be negative, right? So that's my domain for this one. So I'm doing f and g separately, obviously. And here we know that 4 minus x has to be greater than or equal to 0, or negative x has to be greater than or equal to -4, or x has to be less than or equal to +4. So we know that also, right? Does anyone know why we flipped inequality? I know it's kind of a old school concept. Do you know why we flipped it?
Divide by negative.
But why? I'm going a little deeper.
Because I guess the min x like changes. Like if you think like a graph, like it changes the graph direction.
It does, but what if I solve it this way? What if I move that negative? What if I move the x to the right side? I still need to guarantee the same answer, right? So I decided to keep the x on the left side. And I'm going to divide by negative, but you have to guarantee the same results You do that, so it's kind of like going to go from here to San Francisco, right? You can take 280, you take 101, but you end in the same place, right? If you take two of your paths, you end in the same place, right? So it's kind of the same.
So that's why we have to flip when we divide by negatives. Because if you were to move x to the other side, you have to guarantee the same result as opposed to dividing by a negative. Okay, well, let's do this stuff here. So we're gonna combine the functions, and then we're gonna find their domains, right? And then also we're gonna evaluate as well. Okay, to combine them, I mean, it's pretty obvious. Root x plus root 4 minus x. Not that hard, right? So, you can't really do any more than that for the combination. Now, what do you think the domain is? Remember, this domain was x was greater than or equal to 0, and that was x was less than or equal to 4. So you have to combine it. You have to make both happy. Both have to be happy, right? What do you guys think the domain is? 0,4, got it, yeah. And brackets, yes, totally. And if you evaluate, I mean, it's root 3 plus 1, right? Not that hard. So that's pretty straightforward. Okay, thank you, Brooke, for helping me there. How about if I divide? I mean, that's just root x. And by the way, if I don't ask you to rationalize, then don't. Don't feel like, oh my God, I got to rationalize because that's what I did. If I don't tell you to, don't do it. It's fine. Just leave it like that. Now, what do you think the domain would be here? If you go ahead. Yeah, I can't include the 4. And if you plug in 0, you have 0 over root 4, which of course is just 0 straight up, right? Not that hard. Okay, cool. Let's look at reverse it. The next one's gonna be more fun. Composition is gonna be tricky. G over f, so obviously we reverse, so we do root 4 minus x or root x. Boom, boom, boom. Then just reverse, right? 0 is not included, but 4 is included. And if I plug in 2, I get root 2 over root 2, which of course is 1 straight up. So that's actually was pretty easy.
Not too bad. Questions? No? Okay.
Let's keep trucking along here. And I think we should have time to get some homework done today. I'm feeling good about this. All right. Composition of functions. This is a really big deal. Huge. Especially for those who might be doing like ACT later this year, or is anyone actually taking the ACT this fall? Any juniors? No? SAT, okay. Yeah, they will ask stuff like this. Composition, and actually in calculus, it's a huge deal because when you start doing like derivatives and integrals, all that fancy calculus stuff, you're going to be dealing with composition functions all the time. So we have to get used to it. Now here we have an exponential function of e to the x for f, and we have root x. Now just a little tip that we need to say here.
So domain is going to be such that g of x is the domain of f. So you have to be mindful about that. The g is one that's at f. So you got to make sure whatever g is, it makes that happen, right? The g is on the inside. So the term domain of the composite function when it's in unsimplified form. I said anywhere in this process, right? Before you simplify it,
before you look at the final product, anywhere along the way, if it's not cool, if there's a number that doesn't make it happy, you got to exclude it, right? So let's see what's happening here. Let's evaluate. Let's find the function first. And this little dot, this little symbol here, just it's not times, it's not multiply, right? It's composition. Just so just so you don't get it confused. It's not a multiply symbol. It means composition. Did you guys see that last year? That symbol? No. Okay. Yeah. I personally, I like doing this.
that's the way I do it. It just makes sense to me. But it's like, yeah, she's going to have, or the other way around, that's going to be. But to see that, yeah, it's the same thing.
So let's do it first, and then we'll do the domain. So G is going inside of F, right? So you're doing, you can think like this, F of root X. You can think like that. That helps. And what is F in general? So it's e to the root X, exactly. Before I do the domain, let's do G of F. So in this case, you're doing G of e to the X, right? And what is G in general? a root function, right? So it's root e to the x. Okay. Now you got to take a step back.
Okay. Now, root x does have restriction. Of course, x can't be negative. And then e, but you can raise e to any number. Right? That's an exponential. So e to itself, whatever. I can put whatever. But inside the radical, there's a restriction. So clearly, I'm going to say
My domain is going to be from 0 to infinity, where 0 is included. I'm totally going to do that. Okay. Now e to the x. Let's take a step back again.
e to the x. And actually, again, this is why I talk about Star Wars and, understand these functions. Like e to the x of those next ones, once you guys see that, it makes sense, right? Because y keeps getting bigger as x keeps getting bigger. And I see the domains all right? And yeah, who cares? Like whatever I want for x. So e to the x itself is all real. Okay. Now, can e to the x ever be negative? No, right? Because what is e as a number roughly? 2.7 something. And you guys know how that came about? It's kind of like some. Actually, I forgot to know this. I'll refresh the memory that time. There's some funny formula. X goes for infinity. And don't worry about that. It's 2.7 roughly, right? If you raise 2.7 to some exponent, how are we going to make that negative? How can I multiply 2.7 over and over again? My base is positive, right? Multiply it positive over and over again. It's positive. So guess what? What's my domain here?
All real, yeah. The inside will never be negative. It will never ever be negative. The inside's always going to be positive. So I can do whatever I want. Okay, cool. Let's do some tougher ones down below. All right, example 6. So f of g, I mean, I think you guys get the point now. You're doing f of 1 over root x. So it's 1 over root x squared plus 4 times 1 over root x plus 3. I do prefer if you clean it up. It would be nice to clean it up if you can. And I didn't give myself enough space. That's okay. So 1 over x plus 4 over root x plus 3. Let me do b also before I do the domain. G of, oh boy, x squared plus 4x plus 3. So it's 1 over that radical, right? Okay, easy peasy, not that hard. Now let's do domain. I'll switch colors to do domain. Let's go light blue. All right, what do you guys think for A?
I mean, you look along the way, obviously x can't be 0, and it can't be negative. And then when we combine it, just kind of stay that way. So what do you guys think domain would be?
All non-negative.
Yeah.
I know.
Well, actually, all
zero.
positive.
Yes, it has to be positive. Yeah, because x can't be 0 itself. So 0 can't be included, of course. And it's got to stay positive. So yeah. So 0 to infinity. I agree. Okay, cool. This one here, we saw this already, I think. If you factor it, x plus 1, x plus 3, you got to keep it positive. So you got to go to the outsides, right? Not the insides. The inside's not cool. Like if you plug in -2, that'd be a problem. So you got to be from negative infinity to -3. And you can't include it either because it's in the bottom. So let's make that a little more rounded. And then from -1 to infinity. Yep. Okay. Why don't you guys try C? Try C and tell me what you guys got. I'll give you guys a moment to do that. Can I clear the screen? Okay, right. I also have filled out versions of these notes, so I'll try scan when I get a chance. But of course I'll have the video. So yeah, take a moment to do part C. Then we'll do F. Sorry, number 7. I want to talk about F.
Yeah.
Are you guys just doing that? Well, yeah, because Matt, you said that you're done. So I knew he was there. Yeah. It's just what I'm saying. You ready with that? For quadratic, it's like they're all in the first degree, so it's positive, negative, positive, but very right. It's positive, yes, and that's all in the first degree. It's just positive, negative, positive.
Okay. So h is a different function. So we got ourselves g of x squared minus 4, or 1 over root x squared minus 4. You do a little sign chart. -2 and 2 are your critical values. Obviously, it's positive here, negative, positive. It switches. You want to keep it positive on the inside, but you can't include -2 and 2 because then the bottom is 0. That's not cool, right? And boom, boom, boom. There we go. Okay, we're good? Yep, okay, let's move on. Number 7 is kind of open-ended, I think. Find f and g such that h of x equals f of g of x, given that h of x. Okay, if you really want to be smartass about it, you could say this. You totally could say this. You say f of x equals this, and g of x equals this. Is that true? Yeah, it totally is, right?
Yeah, you can do this every single time. It's true. I wouldn't false that. Now, if I put a condition saying you can't make g of x equal x, then of course you think a little more critical, right? But that's true.
That can work. That's one possibility. Or you could do this. F of x equals 1 over root x, and g of x equals what? X cubed plus 1. You can do that. That works, right? Nothing wrong with that. That's totally fine. Let me think of another possibility. You could do f of x equals 1 over x. And what would g of x equal in this case now? Yeah. So you can see there are infinite possibilities. So it's kind of decomposing. So remember, we talked about composition. What's the opposite of composing? Decomposing, right? Yeah, decomposition. Totally, yeah, right? There's infinite solutions here. Or infinite possibilities. It's not really a solution, but infinite possibilities. Just so you know. But if you want to be take the easy way out, you can do the first one. So anyway, let's keep moving. So we got one more page. Now, just so you know, the homework that I'm assigning won't cover, I just looked at the problem sets. Even odd functions is actually going to be the next homework. But I want to do this because we have a shorter class period. I mean, this is unusual. We have 75 minutes. We usually have 60 minutes. But if you see like inverse functions is pretty lengthy. I'm not going to do that today because that's just, you guys have a lot of stuff going on today. I don't want to wear you guys out. See, inverse functions is huge. Transformations also, I don't want to rush that. Parametric is kind of a, did you guys do parametric equations? No? Okay, that's new, right? That's new for you guys. So you know what? We'll do one more page, but the homework won't have problems on even odd functions. They'll be on the next one. But let's just talk about it anyway. Now, does anyone know what even odd functions, what was meant by that? Yeah, it's basically, you look at the next one, it's more specific, it's more about symmetry though. And it's more about how the outputs compare. So let me give an example first of an even function. I think it's good to start with examples and then explain what's happening. Y equals x squared. That's an even function. Graphically speaking, it looks like this. Y equals x cubed. That's an odd function. Graphically speaking, it looks like this. So yes, this is symmetric. sorry for my abbreviation, about the y-axis. But this has point symmetry for odd. That's symmetric about the origin. There's no such thing as X symmetry, don't even worry about that. But the thing is that
Now, yeah, that's an even exponent. Even that's not always going to be
true, because you guys did trig, right? Do you guys remember what trig functions could be even? Cosine, yeah. If you did cosine x, that's yet another one. If you do y, you don't have to write this down if you don't want to. The x squared x cubed is good to write, but yeah, cosine x looks like this, right? I mean, there's no even numbers involved in the equation, but it's an even function. Sine x would be an odd function, right? Tangent is also going to be odd. You guys might remember trig identities, right? Maybe you remember this one. Cosine negative x equals cosine x. Why? Because if you switch the sign of the input, the output never changes. Cosine of like pi over 4 is cosine negative pi over 4. Those are both root 2 over 2. If you do sine of negative x, now the sign of the output changes, right? Likewise here, f of 1 equals f of negative 1, right? But here, f of 1, f of negative 1 equals negative f of 1. They switch, right? So now let me fill out the table. It's even if this happens. If f of x equals f of negative x. But here, f of negative x equals negative f of x. There's a sign change. Okay. And you can put a negative here if you wanted to. It doesn't matter where you got to put a negative somewhere. That's the same thing. Graphically, this means symmetric about the y-axis, symmetric about the origin. I already wrote that down, so you put that there. This is also just getting more intimate knowledge about the graphs,
so you understand, like, okay, you gotta make sure this is happening. So obviously, you gotta make sure this is happening.
So okay. So we're going to determine if these are even, odd, or neither. And I'm going to show how I want you to do it. Also going to show you a quick and easy way just to check to make sure you got it. But I am going to prefer you to go about algebraically. I don't want you guys being lazy here. So I'll do A and B, and I'll have you guys try C. But I want you to determine algebraically, then numerically, then graphically. I know I'm being kind of a hard ass here. But the reason why I care about that, when you can see how all three of those modes are happening and how they're all interconnected, that just enriches your understanding of the stuff. This is when you start becoming a great mathematician, when you can start seeing all these things and how they're all interconnected, right? Algebraically is what you do. You replace x with negative x, see what happens. So what happens when I square a negative? So, and yeah, and if you take a negative to an even exponent, same thing. So f negative x, is it the same thing as f of x? That's even. Now, numerically, I suggest you plug a 1 and negative 1, see what happens. What happens if you plug in 1? What do you get? What happens if you plug in negative 1? Same thing. So because we got 0, sometimes I might want to try a different number just to be on the safe side. So let's say if I did 2, I do get negative 12. If I do f of negative 2, I still get negative 12. So there's no sign change. They're exactly the same thing. Okay. Graphically speaking, this is where Desmos is your best friend, right? Give me 1 sec here. Okay, so y equals x squared minus x raised to the 4 power. Yep. Does y-axis cut that in half? Totally. So that gives you more confidence that you know what's going on here, right? You see everything that's happening, how they're all interconnected, right? So totally. Yep. Okay. Let's try this again for g, or part b, g of x. So g of negative x. So you're raising negative, so you're replacing x with negative x. So you got to use parentheses. Be super OCD with parentheses. Cannot stress that enough. It's got to be super OCD here. So negative x to the fifth. What happens in the next term, guys? What do you think? Yeah, it becomes positive, negative, negative, and then minus x. So in this case, g of negative x, is that the negative g of x? Yep, totally is. If you switch all signs, same thing, odd. And let's do g of 1 and g of negative 1. G of 1 is going to be, yeah, let's do 2 again. Because that's not going to help us, actually. Let's do g of 2. Because they're both going to be 0, and then you're not sure then. Because 0 can't be negative nor positive. If I plug in 2, I think you're 32 minus 16. 16 plus 2 is 18. Negative 2 is negative 32. But minus negative 6 is negative 16. Minus 2 is negative 18. Yeah. There we go. And if you're to graph it, just go back to Desmos again really quickly. X to the fifth minus 2x to the third power plus x. Yep. If you rotate it around the origin, like that's a pivot point, you rotate 180 degrees. That's point symmetry, by the way. That's origin symmetry. You get the same thing. It's in the same configuration, right? Cool. Okay, why don't you guys try C, and then we'll check your work, and then we're done. Go and try C. And by the way, sometimes neither could be a possibility, just so you know. It could be neither. If you see something that's totally different, it's neither. Then it won't have that symmetry. So then you graph one. And numerically, you see different numbers. All right, I'm going to do it really quickly, see if you guys get the same thing. Okay, interestingly, h of negative x will equal the negative of x squared plus 4, right? Because you can factor out a negative from the denominator and then put it off to the left. So it does equal the negative counterpart of h of x. So therefore, this is going to be an odd function. That's why you can't really look at exponents, right? You can't just do that.
Because I see even exponents too. But it's just a weird function. It's a rational function that's got some plus one. It's got a quadratic numerator, a cubic in the denominator, right?
So things get weird when that happens. So you got to test it out. And of course, if I plug in h of, I can't do h of 1 because it's going to be undefined. But do h of 2, that's going to be 8 up top. And so you get 4/3. If you do h of negative 2, I get still 8 up top, but I get negative 6 in the bottom. So I get negative 4/3. And graphically speaking, we'll see that it's a rational function, but it'll be in such a way, even with the asymptotes, don't worry about it. It's still going to have that behavior that's happening. So, all right, good. Great. Excellent. This is the perfect place to pump the brakes. So I'm not gonna do it. First, I'll stop. Let me stop the video.